So hopefully those of you that are joining us can see my screen and know that you're in the right place. We'll be talking all about the ActiveState artifact repository in just a couple of minutes. Just give people a little bit of time to sign in here, and then we'll get started. If you've just joined, we're just giving stragglers another minute or so, and we'll get started right away. We'll be talking today about the ActiveState artifact repository and how to build a secure PYPI using it. We'll just give everybody about a minute here. All right, I think that's good enough. Thanks for joining us today. So we'll be talking today about how to create a secure PyPI using the ActiveState artifact repository. And it's really all about how we can help you ensure that the Python dependencies you populate your artifact repository with are safe and secure for use. And so today, my name is Dana Crane. I'm the host of your webinar. I'm the product marketing manager here, and I've got with me today Evan Smith, one of our product managers.
Hi, I'm Evan Smith, one of the product managers. As Dana just mentioned, I'll be showing you a bit around the platform as Dana goes through the presentation here.
He's going to be my demo monkey today. So let's get started with a few slides just to introduce what we're talking about. So those of you that are new to our open source language runtimes, you might be familiar with the way we used to do this, which was building pre-packaged, pre-built runtimes for Python and Perl and also Tickle. We've now put that on our cloud-based platform, and we can build these things on demand. Now, why would we make a change like that? There's a couple of key reasons that you can think of. An open source language runtime built on demand is going to be using the latest versions of packages. So if you compare that to what we used to do with our pre-built runtime distributions, those ones tend to get old very, very quickly. And that means if you're deploying a pre-built distribution, you're usually deploying older versions of packages, and those might be riddled with vulnerabilities. So not a very secure way to start your project. Another way that people like to create their own language runtimes is just to install it directly from PyPI. In other words, just downloading and installing the pre-built packages directly on their system so they can get up and running on the project. But that also is risky since PyPI offers no guarantees as to the security of the things you're downloading. You may have been targeted before by, say, a typo squatting error, or maybe you've downloaded something that was later found to have a piece of malware inside of it. So those are the kinds of things that when we go out and import the open source source code directly from PyPI, we put a lot of checks and balances in place on our import routine to make sure that we're checking for those typo squatting errors, checking for malware, for Trojans inside of these things. That's actually a lot of overhead. And if you're doing that on a per project basis, that can be quite a lot of overhead, a lot of time and resources being sucked up. So instead, you might consider using the ActiveState platform. Now, the third way that people tend to think about getting their language runtime up and running is by building it themselves from source code. And that's exactly what the ActiveState platform is going to do for you automatically. So we'll take that source code that we've gotten from PyPI, we've had a look at it, we've vetted it on the way in, and then we'll build it on demand. We'll build all those things in parallel. We'll build them for multiple operating system, Windows, Linux, and Mac. And if you're doing that yourself, again, that's a lot of overhead. You've got to create and maintain those build environments for Windows, for Linux, for Mac. You know, if it's just Python code, it's a fairly simple, straightforward build. But once you talk about native libraries, when you're talking about things in, say, machine learning, and you've got to use, they have a lot of LINQ-C libraries, you've got to start building these things with a lot more overhead. And that can really act as a drag. So by using the ActiveState platform, you can return all those time and resources back to your project. Getting this thing done, built automatically for you, is a much better way of freeing up resources so they can work directly on your differentiating features and functionality in your project rather than just building the libraries you need. Another great advantage for the ActiveState platform is you end up with a central location. The ActiveState platform is a cloud-based system based in AWS, and you can centrally build and deploy all of your runtimes directly from that location. That means that all of your developers, no matter what operating system they're using, will always get the exact same environment from the central location. They can download onto their machine and start working with it right away. That can eliminate a lot of those works on my machine errors, which can provide a lot of frustration for developers when they're trying to figure out why something doesn't work. By having a standard environment across all of your developer desktops, you can eliminate those errors. But that also fosters a lot of good, reproducible environment best practices as well, because it's not just your developers that can take advantage of this. Your QA team can. If you've got a CI/CD system that regularly builds containers, they can pull in these pre-built runtime environments to make sure that those environments are consistent every time they run some of their tests. So again, this is going to promote reproducible environment best practices from dev through test all the way into production. And then finally, if you've ever worked with a runtime environment that has tens or even hundreds of packages in it, you've probably experienced some form of dependency hell, where package X doesn't work with a version of package Y that you need, and then you're going to spend a lot of time trying to figure out which version works with what other version of those packages. Now, if your package manager is good, it'll stop you and warn you that the things are incompatible and won't actually corrupt your environment. But most package managers don't go the next step. And that's what the ActiveState platform will do. It'll go that next step and actually explain how to get out of that dependency hell, how to resolve that conflict, and you can do that manually. So in this case, we're talking about Ruby. So the platform supports more languages than just Python. In this case, you can see here that Ruby on Rails requires a Rails DOM testing package between version 2 and version 3, and we're trying to work with version 1.09. So a very simple, easy solution that you can just up that version from 1.09 to something between 2 and 3, and that will resolve the conflict. That's an easy way out, but you might have been left guessing if you hadn't been given a clue. So another good way to eliminate the frustration that can happen for desktops. So with that said, a little intro to the platform, I'm going to kick it over to Evan, and he's going to give you an idea exactly how this works in real life. Evan?
Thank you, Dana. I'm just going to grab the screen here. So as Dana mentioned, I'm just going to give a quick overview of all the things we just saw in action. Just confirming we can see my screen here, Dana?
Yep, you're all good.
Awesome, perfect. So it's going to take about as much time to explain, if not just a little bit less. I'm just going to make up a little case here and try a couple of things. Just to show you this work. So for example, here we're looking at the ActiveState platform just through the web. And I've got a bunch of Python 3.9 projects here. This is a fairly common thing we see with our clients, that they're on an older version and they want to migrate to a new one, but they feel stuck in what they have. So let's say from my point of view, we're on 3.9 and I want to kind of do a proof of concept to say, hey, 3.10 isn't scary, let's try that. So I'm just going to walk through how to do that. I'm going over here to new project, and it's fairly easy to set up. As Dana mentioned there, we support several languages, so Python, Perl, and Tickle, as well as Ruby is in beta. So I'm just going to select Python here. We're on our recommended 3.9, but I want to show off 3.10 here. It's defaulting to the laptop I'm on, Mac OS, but let's say my company is using Windows and Linux, so I want to show them it's easy to set either of these up. Just going to leave them on the latest versions here as well. I'm doing a private project just because I want to prove this out to myself first. I'm just going to add some extra letters to this project so I can distinguish it. And then we have a couple options to get started. I can either search the package catalog, which is all the secure vetted packages that are available on the platform, or I can just start with a Python installation. So I'm just going to do that for ease of use here to get things going. We start at our overview, but I want to go into the details here a bit. So I'm going to jump into configuration. So we can see on this next page that we'll see all the packages have been automatically imported and all the dependencies are resolved. We're seeing any vulnerabilities that might exist inherent to these dependencies, as well as all the packages and versions that are being used. Now I'm not stuck with just using this build. We can either add packages from the catalog or import from file. So here is where you paste your requirements.txt or import the file itself. I'm just going to actually type in Flask here just to show you it can just grab that. And then it uses this feature, which is just called auto. This will grab the version of the package that is most compatible with my other dependencies. And you can see it's also added in all the other dependencies that Flask comes with and resolve those automatically. So it's literally as easy as that. The other flow was to add things from our package catalog. So you can see you've already added Flask. There's some of the popular packages here. And I can just search, let's just search for if there's some Hello World packages in here. And this will show me everything within the catalog. And again, I can do the version selection for these. Now, another feature here is I'm not just restricted to do what's automatically best. I can go and look for a specific package version. And let's say I'm going down into one of the older versions of Flask, so we can see there's a vulnerability inherent to this version. So let's say I have requirements that say, oh, we're using this. If I want to prove out to my organization that, hey, the newer version is better, I can just click right here, 222, doesn't have those CVEs, it loads automatically and we don't have to do anything else. As you can see, it's resolving the dependencies for me. I'm just gonna add a note here that we added Flask to this build, just so I know what's going on. The dependencies are automatically resolved. If there are any errors, they'll also pop up here. And as Data was kind of showing, the error messages give you a little bit of information how you might resolve it. Sometimes it's changing the version, sometimes it's removing the package and trying something else, that type of thing. Really depends on what you're trying to do with your build. We're just going to commit this build, and this just puts everything together for me. We're going to move over to the downloads builds page here in a second. Okay, so we didn't really see much in the way of build time there, but if it was going to take more time to build, we'd see all these packages moving towards success, so I could see the process in order. A nice thing about this too is I don't have to wait around for this build, so this is a fairly simple group of packages, but if we have something larger, maybe multiple gigabytes or with lots of different dependencies, it might take a little bit longer. I can key off the build and I can go away, do something else, drink my coffee and wait for an email notification that my build is ready to come back and review. From here, we can then get our build out and activate our runtime. So there's two ways to do this on Windows builds. And just a note here, that build worked for both of these operating systems, so we automatically got a Windows and a Linux build. So two ways to install this are via an exe file or a command prompt. So the command prompt, literally just throw this in your CLI, and it will run a script that pulls down these packages and creates a runtime for you with an activation. And the other option is we have a package manager CLI tool called the state tool. So you can download that as a separate file and then just run this command in it to grab it directly. Using the state tool just gives you a few more package management options and custom kind of tools and command lines that will do specific things that'll help you kind of configure your build and also change how things are done on your side. Just gives you a little bit more customization options. Now, there's a few different things to go into as far as different ways to get your runtimes and packages out, but that is getting into the point of today's presentation on the ActiveState artifact repository. So I'm going to throw it back over to Dana to introduce that.
Great. Thanks, Evan. Let me just share my screen again. Bring up my slideshow. Let's talk about secure PYPI. So, we love Python package index. It's where we get most of our source code to begin with. But as I mentioned before, that source code comes with no guarantees. So, if you've ever been a victim of typo squatting or had to remove or update a package because a Trojan or malicious code was found in some of the stuff you downloaded from Python, PyPI, that's a fairly common occurrence. What we're trying to do with the ActiveState platform is make sure that that no longer needs to be part of your experience when using Python. And the way that we guarantee that, or help to guarantee that, is through our secure build service. Now, I mentioned our import routine. When we bring things in, we vet it to try and make sure that we catch anything that might be bad up on the Python package index, so even before it gets onto the ActiveState platform. But once it's on the platform, we want to make sure that when that source code gets built, it gets done in a secure manner. Now, some of you might have heard the term SALSA before. SALSA stands for Secure Levels for Software Artifacts, and it's a security framework originally proposed by Google, but now being supported by a wide range of industry players. And really, this is talking about how do I do secure computing when it comes to building and distributing the kinds of packages that we all work with on an everyday basis. And really, they have a number of requirements associated with a build service that can help you understand whether you're doing this in a secure manner or not. And the way that we've done our secure build service on the ActiveState platform very closely aligns with the security framework. And some of those characteristics include being scripted. So in other words, the entire build is scripted. There is no manual intervention required. It operates on a dedicated build service. So this is not happening on some developer's desktop in sort of a one-off manner. It uses ephemeral environments. In other words, they don't hang around to be corrupted or infiltrated by an attacker. You get rid of the environments as soon as the build is done. They happen in isolated steps. In other words, many packages require multiple build steps to get done. Each of those build steps need to be isolated from each other so they don't contaminate each other. Parameterless, we don't want people manually entering parameters into that build because that would be a manual intervention. This whole thing needs to be automated. Everything needs to be hermetically sealed. In other words, the entire build process has to have all of its resources locally to be able to pull and be able to deposit the artifact that comes out of a build step. You don't want anything connected to the internet whatsoever. That offers a point of entry for attackers. It also offers a way for, say, within the build script of a component, it might pull something in maliciously from across the internet. And then finally, we want to make sure everything is reproducible, because that way we can be assured that if every time we produce the same artifact, nothing is being introduced along the way. So given those kinds of requirements, that's how we would define the secure build service, the way that we can guarantee that what you're getting out of the platform is much more secure than something you might be running, say, just as a build on your own desktop or using your own build service. Another key feature here is that we automatically generate attestations. Now, this is something also very new. If you're following US government or you're a supplier to the US government, you may have heard this already. Starting June the 1st of next year, they'll be requiring an attestation with every single software that's sold into an agency or department of the US government. And really, an attestation is a way for them to certify that what you've done is secure. It allows them to trace back all of the artifacts that were used during a build. It allows them to understand where all the source code came from, and it allows them to understand the build process you went through in order to create the artifact that goes into the software that you're selling them. So really a way to guarantee that what you're selling them is certifiable, and they can go back and trace down the security that you've used to create that artifact. Another requirement that we've heard, not only from the US government, but from other companies as well, is the ability to generate an SBOM. And an SBOM stands for Software Bill of Materials, and it's really a way to identify all the different components that go into your software. And the SBOM breaks that down. It not only tells you what components are used, but what those transient dependencies are for each of those components. It tells you the vendor, tells you the version, tells you the license. There's many different things that you can get out of here, the metadata around the software that you're shipping, that the customer can then use to track down things like vulnerabilities or license compliance or other things that might affect whether they can actually deploy this in a secure manner within their organization. So another key requirement that's automatically generated by the platform, so you can give this off to your customer if they require it. And then finally, can't finish vulnerability, or can't talk about supply chain security without talking about vulnerabilities as well. So the ActiveState platform will, as Evan showed you during his demo, flag vulnerabilities. So in this case, you can see Rails has a couple of CVEs associated with version 7.02, but if you're able to go back to a version 6, you can see there are 0 CVEs available here. So what we're doing with the platform is we're tracking down all that vulnerability information, typically from the National Vulnerability Database, but other sources as well, and pulling in that information so that you understand, the risk associated with the version of package you want to use. And because the platform will automatically rebuild this stuff for you, it's a very simple, trivial exercise to choose version 6.15. In this case, if these two CVEs, the medium CVEs, seem risky to you, you can just drop back to 6.15 and eliminate those CVEs for now, wait for an update, maybe 7.03, that might resolve these CVEs. And then again, you can update the Rails package once more. So it's a very simple, easy way to deal with the vulnerabilities that might crop up and can save you a lot of time and effort. So now that we've understood how we can build these packages from source and how we can do it in a secure manner, what can you do when it comes time to distributing them securely as well? And that's really where the ActiveState repository comes in. And the repository, you can think of it compared to the platform as really supporting the way that your developers work today. So if you prefer to work with pip and do pip installs, that's a great use case for the artifact repository. Today, if you're working with the ActiveState platform, we package our own package manager with it, our state tool CLI. It has a lot of extra functionality built into it, above and beyond what pip offers, but that usually means that you're going to have to retrain your data scientists, you're going to have to retrain your developers and how to use that state tool. Maybe that's not something you want to do right off the bat. So an artifact repository can help you work the way you work today by supporting pip. One of the other things to think about is if you've already got a version of Python installed that you work with, maybe something from python.org, and you don't require a version of Python from ActiveState, the artifact repository is a great way to get just the packages you need. If you're using the platform, typically what we'll do is we'll download all those packages along with a version of Python. We'll install it into a virtual environment, and that will be what you use as the environment for your project. So you can run multiple projects with multiple different versions of Python. If you prefer to work with, say, a global install, then that's fine. The artifact repository can support that just as easily. Another way to think about this is over here on the left, the ActiveState platform will populate our artifact repository that your developers can then go ahead and pip install directly from it. But if you've got an existing artifact repository, say like a JFrog Artifactory or Sonatype Nexus, or you're working with one of the cloud vendors, we can easily proxy those artifact repositories as well. So in this case, instead of populating your JFrog Artifactory, for example, with pre-built Python dependencies directly from PYPI, which we know is a risky move, you can instead proxy our artifact repository rather than PYPI. And that way you know that what you're populating into your JFrog Artifactory instance is going to be secure from day one. And that means your developers are always going to be working in a secure manner. So finally, what are some of the use cases that our customers currently use the artifact repository for? We talked about supply chain security. That's the number one thing they're looking for. How can I guarantee or ensure that what my data scientists, what my developers are working with from day one is a secure, vulnerabilities remediated kind of way of working all the way from sandbox through production. But another typical use case, of course, is a curated catalog. A lot of our customers want to make sure that their developers are only working with approved dependencies, and that can be for licensing purposes. For example, you can't work with GPL licensed Python dependencies, for example. So we make sure that this curated catalog only contains the dependencies that fit with your company's requirements. Another interesting use case that we have is from a customer that actually ships their software to their customer to be installed locally. And that customer then wants to extend the functionality of that software. The extensibility comes from Python. And rather than allowing them to go to PYPI and just install any package, what they do is they use the artifact repository to populate it with the kinds of packages that they want the customer to use to extend the functionality of their application. And this way, when it comes time to help troubleshoot, or they call tech support, the tech support people can understand how Python is deployed and which packages they're using. So it helps to shortcut that troubleshooting and helps them reduce the costs associated with supporting those customers. And then finally, I talked a little bit about, rather than using the state tool, you want to use PIP. You can eliminate that retraining or sort of phase in that training if you prefer, instead of having to upfront make sure everybody understands how to work with the state tool. So with that said, I'm going to throw it back to Evan, who's going to give you a little bit of a demo of how the artifact repository can be used. Evan?
Thank you again, Dana. All right. Just going to transfer over here. Alrighty, so here we are back at the ActiveState platform, and I'm actually going to show you coming into a project from a different direction. So initially, I showed you creating a new private project under my own account. What we're looking at now is actually one of Dana's projects. So Dana has so kindly shared this project with me, so I can show you not only can you make your own projects, but you can share them and get access to the builds that are being shared with you and the packages within them. So this is a bit of a different project that I showed you initially, so a bit more complicated, more dependencies and more things going on within here. And let's say we're part of an organization like one that Dana was kind of mentioning. So we do have access to the state tool and we can get our runtime from this. But let's say we've got someone who already is using sort of a pip install flow, but due to our compliance, people coming in and saying, oh, you can't just install everything straight off the internet. You need a more secure something built from source. So they hook that up. They hook their existing pipeline up to the ActiveState platform workflow. So all you really have to do, you've got your existing build here. And with this feature enable, we just go to our project settings, go to ActiveState artifact repository. And here are the artifact repositories that are currently running. We can add a new one quite simply. So all it is doing is taking the commit ID from one of the builds. So on this download builds page, each build gets a unique ID that's also shown up here on the history page. So we can see everything that's happened as well as review old commits. We go to this project setting page. It's defaulting to the latest one, but I can make adjustments to say, oh, I want to grab this older version, or I've got different branches, different variations on a build I want to have artifact repositories for. We give it a unique name, and this just shows up as the slug. So this lets us connect to a URL while still being able to update where this commit is pointing to. So let's say I've got an existing pip install connection. I want to keep the connection the same, but I want to change what build it's pointing towards. I can do that. I don't need to update my users. It's just a matter of redirecting this commit ID. So I'm just going to look at an existing one here. So we're using this previous commit, and it just takes the place of the pip install command here. So just like we were showing with the normal build distribution options, you can just throw this in your CLI, it uses pip install, except it's pointing at our artifact repository URL here instead of to wherever else it could be. I'm just going to dive into the URL here to show you what's in it. So this is literally just the packages built from source and distributed by the platform. And let's just grab one here. Let's go Flask. Flask SQL. And this is literally just the wheel for that Python package. You can see it's available right there, so I can get it this way. But the normal way to do it would just be to use that pip install, grab the URL, and my users don't have to change their workflow. We just have to distribute the access via this updated command. And just a note here for the configurability of this, I kind of mentioned you could change the what the direction it's going towards insofar as which commit. So I can still make those changes. I can switch CVEs, I can add different packages and so on, and then just update the artifact distribution using the same URL via the commit ID, and then we're using the new version, and I don't have to make any changes to my process or send out any types of notifications that, oh, you need to do it this way or get rid of this build, you're on this version. That eliminates a lot of these organizational issues with someone's using the different version than someone else. It builds on one machine, doesn't build on the other. This just kind of unifies things and gives everyone the same way of doing things. All right, throw it back to you, Dana.
Okay, share my screen again and get back to our slideshow. So we've got a little bit of time here for some Q&A. So if you've got a question and answer panel, here it is. You can just pop that open and punch in any question you might have, and hopefully we can get a flow going here. We'll take any of the questions you might have concerning either the ActiveState platform itself or the artifact repository and how that works. If it's not quite clear from what you've seen so far, any questions, just pop them into the Q&A channel and we can get to those right away. So I see one question that's come up. Can I use this with Python 2 or with Perl? Unfortunately, we only work right now with Python version 3.8 and above. So Python 2 is kind of not in scope for us. We do support Python 2, but not in the context of the artifact repository. And Perl, again, is a supported language on the platform, but it currently doesn't work with the artifact repository either. If those are of interest to you, please let us know. I know Evan, as a product manager, is always looking for new requirements. So if those things are of interest to you, let us know. Another question, if I have a private project, does that mean the repository is private too? And if so, how can I set permission access? Evan, you want to take that?
Sure, yeah. So the private project just applies to the project itself. The artifact repository would be public, so any users can distribute it, but it's not locked down with the same security controls as the platform is. But again, as Dana mentioned, if there's a higher demand for that, our initial users were just looking for sort of a public repository that they could distribute. If there are more of a desire for locking down or allowing certain packages to certain distributions, those type of things, please get in touch. We can talk about adding it to our roadmap.
All right. Another question here. Will you support Perl 6 at some point? That's a good question. Perl 6 has been out for a while. We haven't seen a lot of adoption from it. We haven't had a lot of requests from our own customers to this point. We certainly looked at Perl 7 for a bit. Again, that's still under development, but we will go wherever the community goes. So if the community is strongly adopting Perl 6 or at some point Perl 7 becomes the preferred way of going, we will weigh that out. So again, it's really a question of where the community wants to go. We are always about supporting the community. So that is exactly what we will adopt. Another question, can I add my own packages? Let's throw that at Evan.
Yeah, so there's two different things you might be asking there, so I might try to just answer both. So insofar as adding packages, so we saw during the configuration screen there that it was grabbing a bunch of packages based on my selections. You can grab packages from our catalog and add those to your build. If there's a package that you want that's already in the catalog, it's just a matter of either importing it from your requirements file, adding from the catalog, or just typing it in, as I did with that Flask example. The other thing you might be asking here is, can I take a package that I built or a random package that I found on the internet and put it in? And the answer to that one is no. And that just goes back to the building from source. Everything kind of has to go through our vetting process before we get it added directly into our catalog, just to know that everything's coming from a secure build. We are looking more into the future at having some type of way to build packages and go through this vetting process automatically, but it's currently not a self-serve option. To add a particular package, you just have to contact us and our support team, and we just add that to our vetting process package roadmap and get that into the platform for you.
All right. Thanks, Evan. Got no more. One more question just popped in. What happens if I add or change a package? Does the repository auto update? Oh, good question. So what we do is we support a best practice, and typically you wouldn't want to have a package version suddenly change out from underneath you. That can be extremely confusing for people who are trying to work with or test against a current build. Having a package automatically change can be kind of disconcerting. So what we would recommend in that case is you rebuild your project with a new version of the new packages, and then you just add a brand new repository. And that way, if you need to work with the latest version, you can point them at the new repository, and you can phase out that old repository, let people know that that's no longer the most current one, and switch over to the new branch. So that's typically how we would recommend going about that. Another question just came in. When Perl packages are downloaded, why are they stored on your personal user profile instead of cPerl as it was in the past? Yep. So I mentioned this at the start. We used to produce a pre-built runtime distribution that was installed globally. So when you used to install active Perl back in the day, that was installed globally under C:\Perl. That's where you would find it. Today, what we've done is we've moved to, again, more of a modern best practice, which is how do I work with multiple projects in Perl? Perl these days is, there's a mountain of code out there. There are people supporting multiple different projects at the same time. And the only way they can do that is or one of the easiest ways to do that is by working with those multiple projects in virtual environments. So what we've done with the platform is we've allowed for Perl to very easily adopt a way of establishing multiple projects using virtual environments. So today, when you download a version of ActiveState Perl and install it, it will always be installed in a virtual environment. That virtual environment can be designated wherever you want it. By default, you're right, it goes under your user profile, but you can change that on install. You can set it up anywhere you like on your local system. But that is really in support of being able to deploy multiple versions of Perl and support multiple different projects at once, rather than having a single global install, which can be difficult to juggle. Hopefully that's answered all the questions we have here. We'll just give it a few more seconds. If you've got another question, please just plug it in. And if not, you can always hit us up through the ActiveState.com website. Just drop a message in our contacts form and we can answer any question you might have. But for now, I'll just indicate that there are a few next steps. If you liked what you saw and you'd like to get a demo, you can go ahead and schedule that with our product experts. If you want to learn more about the ActiveState artifact repository, we've got a page here that's dedicated. You can go in there and click on that. There's quite a few different things you can read up there, some blog posts, data sheets. I can give you more information. And then finally, if you haven't, please sign up for the ActiveState platform. You can try that for free anytime you like. And hopefully we'll be rolling out the artifact repository for everybody to give a try as well. So you'll be able to test that out very soon as well. And that, I think, concludes our webinar for the day. So thanks everybody for attending. Have a good day.